start with General Jones or you, Glenda.
Yes. I think I probably should come last because we're really responding, and I think that as the various options are described to you, we can say that we are well prepared in all of these options as far as aircraft availability and in most areas as far as ship availability. We've been in touch with forces worldwide, and as you just heard, we've had offer some help from many places. Needless to say, all of the U.S. forces throughout the Pacific and in the Atlantic area have offered their support. But as far as aircraft is concerned and ships are concerned, I think we're equipped and ready for most any of the options that NASA exercises. I think that's all right now.
Well, if you want to, I'll start with a summary of the shift, and then we can go to questions and answers, and the man on my left can perhaps help more than I can with some of the detailed questions you may have in the various areas. Let me start off by saying that we in the business have probably had the longest night we've had in the space program in a while. My team came on duty last night. We were supposed to come on about 10 p.m. and we got to the control center as usual about an hour ahead of time, and some of the men were already there, and the rest of us, I for example, I was in the back room going through the staff support rooms, checking on the status of everything, and we just finished the television show when we found we had a problem. Now, I wasn't on the console, nor did I hear the ground when we exactly had the problem. And let me say that since that time, my team has been primarily concerned with not what happened back there, but what it is we were going to do about it. I'll tell you what I know about what happened, and I probably will only be able to take that so far for you. I'm sure that when we've had time to construct exactly what happened, we'll be able to tell you in more detail what it is we think caused the problem. At about 55 hours and 54 minutes, tank 2, cryogenic oxygen, was fine. Within less than 1 minute, the pressure in that tank had gone to 0. At the same time, fuel cell 3, which was on main bus B, and we have split the buses on this flight. Fuel cell 3 was the only fuel cell on main bus B. Fuel cell 3 went down, and the main bus B went down. We had some restarts on the computer, and they were probably due to the main bus problems. The situation was one then where we had a relatively uncertain situation in that with some of the electrical systems down like that, it's sometimes difficult to determine whether you have instrumentation problems or whether you're having a real problem. However, in this particular case, during the whole course of the action, I think everybody in the control center felt that we had a real problem rather than any kind of an instrumentation problem. The crew reported a loud bang at the time that correlates with the tank pressure going to 0. And they also reported some venting. They could see some things out the left window, and they were getting some rates in the vehicle. Now, the problem with the control system, or the situation with the control system, is that it is split. Some of the thrusters are on main bus A, and some of them are on main bus B. And of course, with losing main bus B, we had some amount of difficulty with control, as you probably recall hearing. One of the other things that happened, which substantiate that something real physical happened, was that the propellant isolation valves on Quad Charlie, we think, closed, which has been known to happen in the past. Started back on Apollo 9 when we did a separation from the Saturn. We noticed that the valves closed. We reopened them with no trouble, but that's another indication that something happened. Now, the area where the cryogenic tanks and the fuel cells are is kind of behind the commander's seat on the left-hand side and down a little bit below what you would call 3 o'clock, perhaps at about 4 o'clock. And the venting and the particles that were being seen out the number 1 window, which again is on that side. So we had pretty concrete evidence that something had happened back in the service module. I don't think anybody fully understands it, but it appeared that something gave way, causing a problem with the fuel cell. Something in the cryogenic tanking gave way, causing then a problem with the fuel cell, probably a physical impact of some kind. And we had about that kind of situation on our hands. Now, Gene Kranz's team was on at the time, and their concern was to, without taking any steps that would jeopardize or compromise the condition of the vehicle, to stabilize the situation as best we could, so that they tried a number of configurations with the jets in order to have proper attitude control. Plus, we were continuing to monitor and go over the electrical system in the hopes of finding something in the instrumentation, but also with the end in mind to figure out what to do about the configuration of the electrical system. Shortly after that time, it became apparent that cryogenic tank with the oxygen in it, there are two tanks, two with oxygen, two with hydrogen. It was apparent that the pressure in the second tank, that is tank number 1, was going down. And this started about the time of the first tank going to 0, but it came down at a very, very slow rate. As a matter of fact, it worked for about 3 hours. We had pressure in the tank enough to feed and make a fuel cell operate for about 3 hours. While the tank was going down, while the pressure in the tank was going down, we performed a number of things in order to attempt to save that tank. The cryogenic oxygen is brought together in pipes and then fed to the fuel cells. The plumbing of the fuel cells is such that if you had a bad leak in one of them, that is a line open or something, it's possible it would operate in such a fashion that all the oxygen would go, find that leak, and go on out. At that time, then, we shut off what we call the reactant valves, which are the hydrogen and oxygen to a given fuel cell, in an attempt to stop flow to a position in the plumbing where a leak might be and where all the oxygen might have been going. That actually was to no avail. We did that in each cell, one by one, picking the worst cell first, and at no time did that change the leak rate. And of course, once we close the reactant valves, we very quickly lose the fuel cell and it is no longer available. We were reluctant to take that step, but it was our last-ditch attempt to isolate a leak. It did not work. At that time, we moved two of the pilots into the lunar module in order to start repairing the vehicle in what I guess we would call a lifeboat mode. We discussed this amongst ourselves in the past, how we would use the lunar module to come on back. Let me say one thing about the trajectory at this time. Of all the times on the way out to the moon, this is probably the most difficult time for a problem like this to occur, because the delta V, or the propulsive maneuver that would be required to come back to Earth directly without going around the moon, had become excessively large. For example, we could have come back with a 6,000 foot per second burn out of the service module. We don't have anywhere near that out of the LEM. But in order to do that, we would have had to dump the lunar module. We would not have been able to get that kind of delta V with the lunar module attached. So that quickly became out of the question with the developing problem we had with the cryogenic oxygen. Quickly, it became clear to us after we had time to review it that the course of action was to retain the lunar module and to swing on around the moon and to prepare to do a maneuver which would in effect shorten the return time back to the Earth. We got acquisition, as I say, we moved, two of the pilots moved into the lunar module at about 57 hours and a half, and about 25 minutes later we got acquisition on the LEM, which meant that the telemetry system had been turned on. The first entry to the LEM was primarily one of just making it livable, the batteries, the power, the glycol loop flowing, etc. At this time it was obvious that the command module cryogenics were effectively lost because we had done all that we could. We wanted to retain an alignment on board the lunar module because we knew we had to do a maneuver coming up, and because it is difficult to do alignments with the telescope while you're docked to the CSM. In order to do that, we put a battery on the command service module buses in order to supply some more power. We did this when we figured the fuel cell had just about breathed its last oxygen. We put the battery on and we used it for about 20 minutes perhaps 30 minutes, while we were performing an alignment, which then gave the lunar module a good attitude reference system. The attitude reference system is mandatory to do a proper burn. It's the system that points the vehicle and the engine, and it's the system that then controls the burn. At about 58:40, as I recall, 58 hours and 40 minutes, we turned the command module power down completely and took the battery off the bus. At the very end, prior to putting battery A on the bus, we had used it previously. We charged battery A for a short period of time in the hopes of getting a little more current in. The 3 entry batteries in the command module, of course, will be the batteries they will use for entry. And I should say that they're in fine shape. The command module, which is the portion of the vehicle which will re-enter, is, as near as we can tell, in fine shape. We have electrical power, we have a coolant system, we have a command module RCS system, 2 of them actually, and all the other systems are still in fine shape. We've powered the guidance and navigation system down, of course, but we can power that back up prior to entry. At about this time, then, we had to start configuring the lunar module in a fashion that would allow us to fly. We were looking at the fact that we knew we had to make a maneuver at about 79.5 hours, which at that time was about 19 hours away, and we knew we had to do that on the other side of the moon, so we started to talk about how best to configure the lunar module to get to that point. We did not want to lose the alignment that we had established in the lunar module, and at the other hand, we didn't want to spend too much power because we are fairly limited in the power that we can supply, and the biggest users in the lunar module are the LGC, the computer, and the platform. So we were concerned with that. However, in my mind, we had essentially a safety problem in wanting to retain the platform. We wanted to do as accurate a burn as possible, so that in my mind there was not too much question about turning the platform down as long as we could get enough out of the consumables to safely conduct the burn and use the lunar module as a lifeboat on the way back. Merlin Merritt, who's watching these systems in the lunar module, was very concerned about the status of our consumables at this time, because when we first powered up the lunar module with the coolant system, larger than normal amount of water was being required to cool the vehicle because it had gotten warm, and the initial flow was taking some time to establish an equilibrium, and we at first were looking at fairly high water usage rates. These subsequently slowed down, and they continued to get better, and as time went by, it became more and more clear that we wanted to leave the computer and the platform up, and that we would have the consumables to do the job all the way home, and I'll talk about those towards the end. At about 60 plus 23, we informed the crew that we wanted to perform a free return maneuver very shortly. Now, the logic behind this was that we had the situation which I've described in the lunar module, and we had about 19 hours to go to the burn to bring us back home. At that time, without any further maneuver, we would not have been returning to the vicinity of the Earth. So we felt it was wise to spend the time and the consumables at that time to do a small burn. It was about 38 or 40 feet a second, which put us essentially on a free return path back to the Earth. This loops around the moon. We're still not sure of exactly what altitude we'll go by the moon. We targeted for about 137, and it'll probably be higher than that, although that's still being tracked and worked upon, and I'm sure you'll hear that number in the course of the day. With this decision, we had to go through the checklist to prepare the lunar module for the burn, and we did it not quite as formally, but perhaps as completely as they do at the Cape when they're preparing a vehicle for launch. Fred went through each page, we went down each page, had everybody in the control center agree that we either had to do what was on the page or could delete some of the items. We were interested in deleting what we could, of course, because some of the things use power, and in the situation we were in, it seemed prudent in a number of cases not to use that power for that particular function. We did the burn, the numbers all available up here, and the burn went fine. The guidance system performed just fine, and the tracking, the Doppler tracking after the burn has all confirmed that the burn was nominal as we had planned, which is another good indicator that the platform or the reference in the lunar module is in good shape. I'll review the consumables at the end of this. Let me tell you what is coming up. At the present time, we're in what you might call a modified passive thermal control mode, where usually on the way to the moon, we're rolling the vehicle, and it's standing up. If you look from the Earth to the moon, it's standing up and it's rolling to get a equal temperature distribution from the sun. In this case, what we're doing, since we don't have a good control mode to do that from the lunar module, we're just cycling the vehicle about every hour through 90 degrees so as to equally heat and cool both vehicles, both the command module and the lunar module. That's going very well, and it takes not too much attention on the pilot's part, and we can look at that data on the ground and be sure as we go along that the attitude control system's doing the job. We have had some poorer than usual comm in the last few hours. That's because we've taken a power amplifier, which is essentially just a booster for the comm, and taken it offline, and we've got comm equivalent to what we used to have over some of the ships in the Mercury program. It's saving us 2.5 amps, and at the present time, people are being as stingy as possible. At 79 plus 30, although there's still discussion about doing a little bit early. We have considered and are still considering what the possibilities are for dropping the service module, which is a large amount of weight, in order to accomplish a faster return to Earth with the lunar module engine. There are a number of considerations involved in this, not the least of which is the new thermal environment which the command module heat shield would be exposed to. Of course, it has never flown in space like this. It would have never flown in space like this without the service module on, and there is some concern about what would happen to it if we did not have the service module on there. I say again, the reason for considering dumping the service module is that you can speed up the return and perhaps, and this is really a perhaps, land a day early, but you would end up using just about most of the dip's fuel, and you would be probably have a little bit less than we would comfortably like to have. I say that this discussion is still going on. These kind of options are still being entertained, and sometime in the next few hours I expect that we'll decide exactly how we want to do the upcoming burn, and you'll probably hear it on the air to ground at the same time I do. We will probably do something else on the way back after the burn. We'll probably turn down the guidance system on board the lunar module, since it is a fair user of power, and it also has to be cooled, which causes it to use water higher than if we were able to turn it off. The water usage is higher with the guidance system on. We will probably also consider going to a duty cycle on the communication system in order to again save power in the lunar module, and probably at some point power up the comm on some schedule as opposed to having it up all the time. Those things are in the future, and you'll be hearing more about them. To give you some idea where we stand on the LIM consumables, right now with the water that we have in the lunar module descent and ascent tanks, we can follow the profile that we have intended to follow. That is powering down the primary guidance system after the first burn, and power it up 2 more times for mid-courses, and land with still about 12 or 13 hours of water of cooling available. So that is beginning to look like we are in reasonable shape there. We are also studying some ways, possibly getting some more water into the coolant system, and we're not sure how those are going to work yet. On the batteries, we again are planning to follow a course which will end up with about 500 or so amp hours left, which is about 22% of the current or the power available in the lunar module. So that's beginning to look like a fairly comfortable margin. Of course, that is dependent upon following the power profile that we've laid out, and you'll hear people talking about a couple of amps all the way back, and the intention is to follow the profile. I don't have the O2 prediction, but that's generally better than the water in the power. The lithium hydroxide canisters, we have about 50 some hours for the 3 men with the canisters in the LEM, and we are preparing a few techniques for using the canisters and the carbon dioxide scrubbing, which is available in the command service module, and you'll hear some more talk about that on the loop, I'm sure. I think that about summarizes what I can say at first blush, and perhaps my comrades and I can help you with further questions you might have. Brian?
All right, we'll take questions if you'll wait for the mic. Let's start with Roy Neal. He's the first up.
Glenn, you've described the situation accurately in terms of hardware. How critical is this situation right now, in your opinion?
Well, I think it is as critical, perhaps probably the most critical situation we've faced so far in the manned spaceflight program in flight. We are about 70 hours from home, and we think we have the situation in control. We've projected the consumables as I've described, and we have a plan for carrying out the rest of the mission, but there is going to be no relaxation at all as far as that goes from now until splash.
The oxygen situation.
The oxygen? I didn't bring in numbers. Merlin, can you talk about
yes,
oxygen?
The oxygen situation, we're, I think, in pretty good shape. We have about 160, or we should have enough to complete O2 requirements for an elapsed time of about 165, 170 hours elapsed.
In other words, we could fly that long with the lunar module oxygen. And I should be very careful to point out that we still have the normal command module oxygen supplies intact in the command module. Those are used for entry and post-entry work.
Henry Simmons. I gather that what was the most critical single thing that had to be done last night? Was it getting that reference platform set up on the LEM before the collapse of the command and service module power?
Well, in my opinion, the most critical thing was people keeping cool and getting done what had to be done. And I think we were able to do that. I think especially the pilots remained cool throughout the whole thing, and so far we've been able to stabilize the situation, and we have every intention of keeping it that way.
What happens if you do run out of water before you come back in? And secondly, it is my understanding that if you went on the suit loop, you might save some oxygen or conserve somewhat. Is there any consideration of this?
If we run out of oxygen, or if we run out of water, it will get warmer in the lunar module. We'll probably have to do something about orienting the vehicle to try to cool it. Usually we try to equally heat it on all sides, but I suspect if we really ran out of any coolant water, we would go to something like that. There's plenty of drinking water in the command module, although we have to pressurize the system to use it. There's some extra drinking water in the LEM. I don't recall how much. And you asked me a second question. The cooling in the command module is just fine. We just aren't using that system at all. That's buttoned up right now. But all the cooling capability in the command module is still there. And as I said before, the command module itself is completely intact. Oh yes, going on the suit, but we only have 2 connectors in the lunar module for 2 pilots. And Merlin, you want to comment on the usage?
If I may, yes. No, I think that's incorrect. It would be preferable to remain in an open atmosphere. That way the usage rate is not as much as if it would if you went on a closed suit loop. Besides that, we only have the capability to maintain 2 crewmen in the LEM in a closed suit loop.
No, in order to do anything now in the command module, we'd have to turn some equipment on. So we just got the door open between the two vehicles and letting the command module or the lunar module oxygen come over now. We've sealed up the command module system. Okay?
We have a suit compressor that circulates the air, the atmosphere in the cabin through the suit loop, which does remove CO2. So
Something last night about moving one of these hoses so it would move the carbon dioxide or something out of the command module.
yes, we did move a limb hose, stick it up through the tunnel area such that it would circulate O2 into the CSM.
That was to blow fresh oxygen into the CSM in order not to get a buildup of CO2 while the men were sleeping in there, one man last night.
Answers anywhere that'll give you a chance to draw some inferences about the condition of the heat shield after that explosion or impact behind it?
I didn't hear this first part of your question.
Do you have any grounds for drawing any inferences about the condition of the heat shield after you had this explosion or impact behind it?
I don't know whether we do or not. I assume people are looking into that, but I don't know.
Can you say the life of the astronauts is complete security this time?
I'm sorry, I didn't copy all
the
that.
The life of the astronauts is security, health security, the life of the three crews. And the second question, is in danger the life of the astronauts?
Are the astronauts safe, I think is...
Well, they're safe in the sense that we have the situation stabilized now, we think. I think our only concern about safety is that we're now about 70 hours from home, and we have to continue to keep the situation that way and bring them on home. And you had a second part?
The second part, can you explain what is the reason don't start the return to the home before of the go to the moon? Before of the moon, can you return the command module to the Earth?
If you're asking if we're bringing the command module back to Earth, we're gonna fire the engine and bring both vehicles back to the vicinity of the Earth. At some time, of course, the pilots will button up in the command module and power it up for entry, and they will separate from both the service module and the lunar module. Where exactly, I can't tell you. We've had some contingency procedures for where we would do that, and I'm sure they're being looked at and reworked right now to get an exact timeline as to how we would jettison both of those parts of the current stack.
After the dips burn as you plan it now, what sort of mid-course correction capability do you have, and what sort of mid-course corrections do you think you'll need?
Okay, of course, the burn that we're going to do is, as I said, still being discussed in the sense that we could do a reasonably average size one of about 890 feet per second, or we could do a much larger one which would use most of the fuel in the dips burn. The difference in those two burns is that for the smaller burn we would land at an elapsed time of 142 hours. For the larger burn, which runs closer to dips depletion, we would land at 118 hours. And you wanted me to relate that to?
The mid-course correction
The mid-course as
capability.
well. The way we plan and target the burn, we don't expect to have any, but with the shorter burn or the longer return time, we would have a considerable amount of delta V available in the lunar module to correct it. With the larger burn and the shorter return time, we would have less than that, on the order of a couple hundred feet per second in the LEM descent propulsion stage.
We have about 3 questions in the second row we'll pick up.
Can you tell me where Fred Hayes slept during the night, and can you also tell us if the ground controllers ordered the 2 LEM pilots into the lunar module last night, or did they go in on their own?
To the best of my knowledge, Fred slept in the command service module, probably on the couch or maybe on the floor. I don't think that we had to order them into the LEM last night. I think as the situation was stabilizing in the command module, and we knew that we had the kind of problem that we did, I think they were on their way when we finally got around to talking to them about it. As a matter of fact, we were just picking up with the procedures to activate the LEM. And I assume that they were on their way with the hatch work by the time we got to talking to them about the procedures.
When you send them up the information for that small burn last night to get back on a free return trajectory, the kind of information usually includes a weight figure for the spacecraft, and that had obviously changed because of the venting. How did you know what weight to give them, and how are you going to handle that problem on this big burn?
Well, the weight that you're talking about is the weight of the total command service module. The purpose of giving that number is to have the guidance system do the most accurate job that it can in guiding the burn. Now, we have a number of people who try to make that number accurate to the nearest ounce, but in all truth, the guidance system can perform quite properly, even if it's off by a large amount, several hundred or several thousand pounds. So whatever we assumed about the weight when we sent it up, it really wouldn't make any difference to the burn.
Is it right to assume that whichever of these TEI burns you do, you will have reacquired the spacecraft after it's passed behind the moon?
Yes, sir. Let me say one more thing that you just indicated. These burns will be performed after we go around the moon and on the front side. They won't be conducted in the usual TEI fashion behind the moon. They'll be conducted about 2 hours after acquisition, after they come around. Okay?
Could you tell us, please, whether there have been any private conversations with the crew and whether any are planned?
There have not been any, and I don't know of any planned.
Do you gain any flexibility from the fact that the ascent propulsion system is there? Does that enter into your contingency planning at all?
We could use it. It's a more difficult task than the burn in the descent stage. Hal, you want to talk about it anymore?
Yeah, right now with the ascent propulsion, we have in the neighborhood of 720 feet per second delta V capability. But to utilize that, you're going to get rid of the descent stage, which we don't want to do. And we do have adequate margin in the dips right now, so we're not really entertaining any idea of using the APS, but the capability is there if we need it.
APS is ascent engine.
If you do the super fast return, where would the splashdown approximately be?
Tom?
What was that question
He
again?
wants to know where we would land if we came back at the 118-hour time.
Okay, the longitude is about 179 east. The latitude's about 1258 south.
I'd ask General Jones to comment on that, too, as to what his posture would be.
Well, in that particular case, as you will recognize, it's just a few hundred miles west of the normal landing point, and the position of the Iwo Jima is such that it can be positioned between the, well, in the center of several landing options, and at this point in time we see no problem in being able to reach the landing point ahead of landing. And by the same token, we can cover a normal, with normal aircraft dispersal from Hawaii or through Pango if necessary.
Are you still contemplating splashdown in the Atlantic area? And could you name the nations in that area that have offered to assist if necessary?
Well, I guess we're considering it, but it's probably on a pretty low priority. And I know that the recovery folks have been assessing what is there. General Jones, can you say anything about that?
Yes, we have aircraft, of course, at Ascension. We could not have a trained recovery ship in all areas of the Atlantic, but we could cover the landing with HC-130 type aircraft, and there's no reason to expect that we couldn't have fairly quick access by surface ship. But we have no specific deployment of surface ship in the Atlantic. South Atlantic.
I have two questions. First, Glenn, I'm still a little confused over why you're using the LEM for this burn as opposed to the service module. And secondly, is there the possibility that a meteorite hit could have caused the situation that you described earlier?
By this burn, Roy, are you referring to the one coming up or the one we just
Coming
did?
up, right.
Well, the reason we want to do the burn with the descent engine at this stage of the mission is primarily that we don't want to do it with the service propulsion system. We've had a problem, probably a physical rupturing kind of problem in the service module area. To attempt to burn would be to deal with just an area of the vehicle that wasn't as completely clean as we normally do the service propulsion burns. What I'm trying to say is something else may be wrong in the service module area. In addition, it would take power out of the batteries, which are used for entry and landing, in order to accomplish such a burn. We can transfer a certain amount of power from the lunar module, but that lunar module, of course, is critical. We can transfer 15 amps, but 15 amps doesn't do you much good at all when you're talking about powering up a control system and gimbal motors to do a service propulsion burn. So for both of those kind of reasons, we are going to stick to the descent burn. And you asked me a second one.
The second question was, could this situation have been brought on by either a meteorite or a micrometeorite? I realize that's conjecture.
I don't know. I guess it's conceivable, but I guess it's conceivable, but based on the fact that the cryo pressure, that is the pressure in the cryo tank, started to go up, reached what pressure it should have relieved at, and then went on down to 0, my personal is that probably has not occurred, but that again really remains to be seen. We have established by the burn a few hours ago the situation where we are returning to there, and we wanted to establish that.
All right, we're going to be able to take just a few more.
On the, you said you could get 15 amps out of the LEM back into the command module. Is that sufficient to power up the optics?
Yes.
Do you think then you will use the CSM optics to try to
Yes.
get better angles?
We are writing a procedure and having one available to use the CSM optics either through the route I described or possibly even out of an entry battery on board the command module in order to possibly check the results of the program 52, which is the alignment program that the pilots will do when they go in the shadow of the moon. However, at this time, that possibility is exactly that. We are considering using that system or that technique to check the alignment results, and we have every confidence that the alignment itself, once we get in the shadow of the moon, will work out fine in the lunar module. And I should say one more thing about that 15 amps. If we really return at the end of the flight and find that we do have the electrical margin in the LEM, we can charge up the batteries in the command module, the entry batteries. One of them is down, I think, about 22 amp hours out of 45 or 50. We could charge that battery back up if we indeed found ourselves close to entry with a comfortable margin on the LEM power.
Okay, we're going to cross the front here, and Mary Bub had one, and Harry Pease, and we...
Well, at this point in time, where is your most serious concern to bring the crew safely home? Is it in in what area of hardware or consumables, or in your opinion, where is the most serious area?
I guess the only way I can answer that is in the 70-some hours we have to go. I really couldn't pick anything that was more critical than anything else, but I think it's the time factor now that we're just going to have to watch and be sure that we continue to operate the vehicles in such a fashion that allows us to live and operate effectively that long in the lunar module, or else we're going to have to go in the command module and start using those batteries, which we don't want to do.
General Jones, can Iwo Jima reach the landing area, the 142-hour landing area, in time to meet them?
I'm not sure. Well, yes, we can reach the areas that have been mentioned in terms of planning. It is now somewhat south of that, but it'll move to now is moving toward a position which is, will about split the difference between the two landing areas that have been mentioned. Not the free return, not the free return area, but the areas in mid-Pacific.
I'm speaking of the one with a landing at 142 hours GET, which is something like 600 miles south of Samoa, as I plotted the coordinates.
Yes, it'll be able to reach that.
Louis Alexander in the second row has been waiting.
Glenn, how fatigued are the astronauts, and how much rest are they likely to get?
Well, I guess you can tell as well as I, from the sound of their voice, I think they've had a long day. This actually started to happen at about the end of their normally planned day yesterday or last night, and as everyone can tell, we've been working at a fairly busy pace since that time. We do have some sleep time or rest time scheduled for them, and I think they'll take advantage of that and continue to perform. I'm sure they'll be glad when the next burn, the one at 79.5 hours, is behind them, because that'll give them a little more opportunity to relax. And we'll just see how they sound as we go along, Louis.
This is going to have to be the last one. This has been a very long shift for these men. Zach, you have something, then we can...
Glenn, when do you have to exercise these options? How much more time do you have to mull over all the problems and decide one way or another what you're going to do?
As you would expect, and I'm sure you who have covered the flight know, we'd like to be sure that we've thought out all options as long as possible. But I would suspect that within several hours of the planned burn, and getting it ready to take care of the pilots. And I think we're going to decide several hours before this upcoming propulsion opportunity. And then we're just going to press on fairly single-mindedly with that approach.
Thank you very much.
As usual in the last 8 hours.
Okay. When we came on this morning, we had already performed the mid-course from last night that I'm sure you've already been briefed on, and the vehicle was in passive thermal control mode, satisfactory calm, and we went around and briefed in the room. We are then and still are on a comfortable trajectory in that we are well within the corridor. Flight path angle of about 1/4 of a degree away from what we aimed for. During the night before we came on, they had a battery 2 malfunction, which was reported to me at the last press conference I was at, by the way. We had that blinking, still do, a number of times off and on intermittently, but we have pretty firmly concluded that it is only an instrumentation problem. We're continuing to use the battery, and the battery's performing fine. That battery is one of the descent batteries, battery number 2. We had turned on the telemetry last night, the thermal data that we were interested in getting, the temperature data that we're interested in getting from the vehicle. Gave us a lot of confidence that
that the vehicle was in good shape. I'm speaking now mostly about the command module for entry. We had been on the LEM power. We had hooked up the umbilical from the LEM to the CSM to enable us to transfer power to the command module. This connection is capable of transferring up to 15 amps only. And when we came on duty, we were just starting or had just started to charge battery A. Battery A, you recall, was the one we used some while ago when we were powering the CSM when we were leaving it, when the fuel cells were going down, and that was down about 22 amp hours. So for the last few hours, we've been in the process of replenishing that battery, and we expect to have it fully back up to charge, sometime around 127 or 128 hours elapsed. We had been on, you recall I discussed yesterday, the fact that we hooked up a couple of the CSM lithium hydroxide canisters through which the cabin air was being drawn. The canisters were hooked up on the end of the hoses to cleanse the air of the carbon dioxide. We were on those systems for 20 hours, and we just began to see a very, very slight rise in carbon dioxide measurements. We were up to about 1 millimeter, 1.5 millimeters of mercury, at which time we decided that we would put another canister on the end of the one we had already had rigged up, so that we now have two canisters in series, taped together so that there's no leakage between them, feeding into the hose through which the air is being drawn into the suit loop. So we are continuing to get good scrubbing or cleansing of the carbon dioxide in the vehicle, and we feel that the present arrangement of removing the carbon dioxide will last just fine into the 130 hours sometime, perhaps 135 hours thereabouts, and by that time, if we see the carbon dioxide level going up a little bit, we'll probably go back and select the primary cartridge, which we still have available in the LEM, which will be good for about a day. So at the present time, that's our plan relative to the carbon dioxide. At about 113.5 hours, Jack Swigert and Fred Hayes went on duty, and Jim Lovell went below to take a nap as best he could. Fred reported he had 5 or 6 hours sleep. We have, since that time, not really been doing much with the vehicle. We have had the pilots going back and forth, who's ever on duty, down into the command module to look at the charger currents. This is to keep track of exactly what we're putting in the battery so that we will know what we have in there and we'll know when to terminate the charge. We also want them to go down there and look at that gauge regularly because we don't have any telemetry on the vehicle, and we didn't want anything going on down there that we didn't know about. Discussed the battery malfunction. We had another one visible to the crew for a while at 115.5 hours, I think, about. And we discussed it again, the fact that we had concluded that it was a sensor, and as I said before, we're continuing to use that battery just fine. We radioed up some information on the trajectory. As I said earlier, we're comfortably within the corridor at a flight path angle of about negative 6.25, a mid-course of approximately 2 feet per second. A few hours before entry will put us right back in the middle of the corridor. However, it may not even be required. At last measurement, the mid-course was down to 1.5 feet a second, and for all we know, by tomorrow, the mid-course will be closer to 0, although it may also still remain at the present level. The one report relative to crew comfort is that it's getting fairly difficult to sleep in the command module in that it is getting fairly cool in there. Jim Lovell reported that he's been using the Lunar boots to keep his feet warm, and yesterday we were involved in a discussion as to one of the pilots, I've forgotten which one it was, sleeping in the tunnel, up with his head probably pointing into the lunar module, or perhaps his head pointing away from it. There's not much we can do about that problem right now, so they're going to have to sleep the best they can, either in the LEM or in the tunnel, and stay dressed as warmly as they can on board. That was the shift items. Let me give you an idea of the consumables, and I know you're always interested in those. We discussed the water yesterday. Well, I should say consistently, the water has been running at about the same rate. It's running at just about the same rate now as it was before. You know, we're drawing a little more current out of the LEM batteries now in order to charge the command module battery, but the water profile is staying just about the same. So consistent with the kind of information I was giving you yesterday, assuming that we have to power up for one more mid-course, we're predicting a lifetime on the water of 160 hours, 159 hours. The oxygen is very comfortable. We have a depletion in the LEM of 271 hours, so that's well past the splash time. Depletion of the power at the same rate, except for about 2 hours, if we assume that we continue to use power at the same rate, and add in a couple hours for a mid-course, we would have 170 hours of depletion. Now, it's probable that we will use more power tomorrow than the numbers I'm quoting here, and get as much useful work out of the LEM in terms of transferring its power over to the CSM as we can. The details of exactly how we are going to accomplish some of the functions tomorrow are not all completely resolved yet. We had a briefing just as I left the control center with the crew as to the timeline, the major events. I assume that everyone heard those as to the sequence of events we would be going through in preparation for any actual entry. Some of the details within those events are still being worked out. We've had crews in simulators all day. There'll be another meeting this afternoon on exactly what the checklist ought to be. And as the Capcom Joe Kerwin was saying, we will spend some time later on this afternoon, this evening, reading up a lot of the checklist that the pilots will need for tomorrow. We're basically going to be modifying the checklist that they have on board, and a number of the parts of this activity tomorrow have already been exercised. There was one more thing I wanted to tell you. The weather is very good in the recovery area. Oh, I know what I wanted to tell you. I have asked that somebody plan either in conjunction with the next press conference or separately to perhaps lay out as well as we can the timeline and the activity that will be going on tomorrow so that you'll be as informed as we can have you at this time. I'm sure there will be a lot of questions. Some of them I won't be able to answer in the next hour, and I hope that sometime this evening we can satisfy most of your questions on the details of what's going to happen tomorrow. The weather is good in the recovery area. As a matter of fact, it's very good. And I think that's about all I have to say, and perhaps we can find what you're interested in by going to questions now.
Okay, front row down here. Wait for the mic, please. Do you have a two-part question? Do you have an estimate of how cold it is in the command module? And number two, if, as I assume, the lunar module is reasonably warm and the command module is cold, why don't the temperatures sort of even out going through the tunnel between them?
I don't have the temperature in the command module. I think it's running about 40 or 45.
It was 52 at 102 hours, but it's probably cooler than that.
So it's probably cooled down. We will be turning the telemetry on here in about another hour, so we'll get another idea of what's in there. I guess the reason that it doesn't mix too well is because the tunnel is fairly narrow compared to the two volumes on either end, and there is not a lot of flow out of the hose that would force circulation. There's enough circulation in that there's no problem with the carbon dioxide level in the command module, but there's nothing working that forces the flow between the two ships. It's about 3 feet.
Mark Bloom.
Glenn, if you do MCC7, and assuming it's 1.5 feet per second, how will this move the ground track from which, or what's it for? What would it be for?
It would be simply for what is called corridor control. The flight path angle, or the angle at which the the velocity of the spacecraft, the velocity vectors coming back in, is currently at a negative 6.25. Now, if we do a mid-course tomorrow, the purpose of it will be to put that flight path angle at a negative 6.5, which is the nominal entry angle. The current angle is very comfortable. We could fly the same range without a mid-course at all. We could fly the trajectory right on down. We could fly the same range and probably land at the same place. The reason for wanting to put it in the middle of the corridor is just to give you the most room for dispersions on either side, plus it's the most familiar set of conditions for the pilots in that they've seen more nominals than they have dispersed trajectories during entry. Okay?
Fourth row back here.
Could you tell us, please, the astronauts who are taking part in the simulation other than the Apollo 14 crew?
That would be a long list, and I haven't kept up with them. The 14, the backup to Apollo 13, seen the Apollo 15 crew members around. Deke and Tom Stafford are helping all they can. And there are probably a dozen more, but I can't recall who they are right now.
Front row over here.
Have you seen any signs of anything you might describe as fatigue in the crew so far?
No, I don't think so. I think they've been, I think they improved through yesterday and today. They seem to me to be at the same level of operation, and I think tomorrow they will go through their own process of bringing themselves completely up for the entry, much as anybody has to do to prepare themselves for an event like that. And I think the best indicator is the tone of voice of the pilots, and it's been very good.
Were they fatigued earlier, or did you get that impression?
I didn't really get the impression that they were tired. Somebody asked a while back, I recall Fred Hayes, I believe, answering that they really felt pretty good and they really didn't feel tired or fatigued.
Back here.
If it's so cold inside the command module, why aren't they wearing spacesuits? What are the differences?
The primary disadvantage to putting the suit on is that it is bulky and it limits what the people can do. It's cumbersome to try to squeeze around in either the LEM or the command module, especially if you're trying to squeeze through the tunnel. And we've kind of had, with one man on watch, we've had him busy moving back and forth so that they just haven't felt the need to put the suits on. Now, that's entirely up to them. If they feel that if it is just so cold that they want to do that, they certainly go ahead and do it.
John Wilford.
Under the plan for the separations that you have now, where will the lunar module re-enter and where will the service module re-enter in relation to the command module?
Well, I hope that the men who come over this evening can tell you some more about that. I don't know offhand. Of course, we fully expect both of them to splash down in the Atlantic. The separation sequences that we have are primarily designed to be sure that they're away from the command module during the coast above the atmosphere and during the reentry portion. So I'm not answering your question, but I hope that they can help you better with that tonight.
Back here.
Why aren't you going to be using the normal technique for jettisoning the limb rather than letting it be pushed by that pressurized tunnel?
Well, the reason for that is that we don't have the service module. We would not have the service module with us. The normal procedure for separating from the LEM is to undock from it and then translate away with the service module thrusters. At the point of the flight that we'll be at, we will have already detached the service module. The command module does not have a thruster configuration that allows it to translate. It can just rotate, pitch, or yaw. Okay?
There was some discussion about the possibility of the astronauts getting into their spacesuits just prior, I believe, to jettisoning the LEM after they put the tunnel hatch in place. What was the final decision on that score?
Well, to clarify your question, the question really is whether they ought to put their suits on before we go into all the entry preps for tomorrow or not. As Joe Kerwin, the capsule communicator, discussed on the loop, the advantage of having the suit on is if there's any problem with a leak in the command module hatch. We have not experienced any problems like that, and we are able to exercise closing the hatch now, and as Jim pointed out, they will do that a number of times. The disadvantage with putting the suit on is the same one I discussed earlier, that the so it's a question have to do tomorrow.
Just about the time we're getting started in the numbers that you've been giving us on the water and on the power really you give us some numbers which would seem to imply that there is a large buffer in some of these consumables, or at least adequate for doing the mission without any sweat. But it seems that now the decision on the suit doesn't reflect that, and that whatever little amount would be needed to dissipate the body heat, they're not willing to expend it for a period of several hours that they might otherwise do so.
Each time that at least I have quoted the numbers to you, I have tried to carefully explain that they are based on the current rate of expenditures, allowing for 2 mid-courses 2 days ago, and allowing for, from this period forward, a couple hours for 1 mid-course. The numbers that we've been quoting are consistent with that. Putting the suit on is an additional load. I don't think it's an overriding factor in determining that the water availability would be much more marginal than it is right now. I think the primary reason for not wanting to put the suit on is that it definitely encumbers the operation of the astronauts in getting the ships ready to do the tasks they have to do. An additional argument for not putting it on is that they'll get warmer and we'll have to dissipate the heat, but I personally don't consider that an overriding reason for not wanting to put the suit on.
Mary Bob?
Glenn, I have several questions on the crew and, how they've been living in space. You mentioned that they're having difficulty sleeping in the command module. Where have they been sleeping, first of all, and wouldn't those beta sleeping bags provide some warmth?
Well, I assume that they have continued to go down into the command module to sleep. I don't know what all they're doing to stay warm while they're down there. Jim talked about putting the lunar boots on.